Hey Geometry, so today we're going to take a look at segment and angle proof. Start out with an example of one here. So we're given that angle 1 is congruent to angle 3, and I always recommend you can kind of mark up your diagram. So angle 1 is congruent to angle 3. We know that much, and then we know that measure of angle TXU, those measurements are equal, means those angles are congruent. And then the measure of TXU, which is TXU, so this length right here, I'm going to do like a couple, like there, that length is congruent to TXC. So going out this way, that's congruent to those angles. So kind of tough to mark that up sometimes, but I'm going to attempt to do it in that way. And ultimately we want to prove that angle 2 and angle 4 are congruent. So first of all, a lot of times we do all of our givens first here. They just did half of it. The TXU is equal to measure of TXC, so that's a given. And we can kind of peek through and see, where did this come in? This given is going to need to be stated somewhere. They brought this down on line 5, so I'm actually going to go ahead and label that as given as well, so I don't forget when I get to the that's given. So a lot of times that'll be done on the first step, but here they've snuck that down there later where it's going to apply some more. All right, so TXU, measure of TXU, is equal to the measure of which two things? TXU is this angle, so that's actually angles 1 and 2, and that is the angle addition postulate. And then we can also say a similar thing for TXC, this angle here, 3 and 4. Angles 3 and 4 are congruent, and that's again from the angle addition postulate. And so then you can think of this a couple of ways. You could call this substitution, or since we know both of these are congruent to each other, a couple of applications of transitive property, but I'm just going to call it substitution, because basically TXU, which is angle 1 and 2, is equal to TXC, which is 3 and 4, so we're going to just call that substitution. And then we bring in our given, angle 1 is congruent to angle 3, so then I'm going to replace here angle 1, what was angle 1 on this line, with angle 3. So this is going to be a measure of angle 3 now, and now I've got an angle of 3 on both sides, which we'll use in a second. So that was another substitution property, if you want to be proper about that. And then we subtract the measure of angle 3 from both sides, so that is the subtraction property of equality. And so we end up with the measure of angle 2 is equal to the measure of angle 4, which is ultimately what we wanted to prove there. All right, so we've got some of these same properties that we've seen before applied to congruence as well, both for segments and angles. So the reflexive property would be like segment AB is congruent to segment AB, or angle 1 is congruent to angle 1. All right, if we ever need to make the statement like that, we can do it that way. The symmetric property would be like segment AB is congruent to segment, let's say BC. Well, so if that's true, so I guess I'll put a little if, then segment BC is congruent to segment AB. Or we could write for angles, angle 1 is congruent to angle 2, then we could write, so I guess it should be if then technically, if then angle 2 is congruent to angle 1. We can flip-flop them, symmetric property. And then finally the transitive property, if like AB is congruent to BC, and so this would be, I guess, an if AB is congruent to BC and BC is congruent to CD, and you could use all brand new letters for this too. It doesn't have to be reusing the B or whatever, but just an example of that. Then AB is congruent to CD. Segment AB is congruent to CD. And we can do something similar for angles. If like angle 1 is congruent to angle 2, and angle 2 is congruent to angle 3, and then angle 1 is congruent to angle 3, right? So if and then. And that is for both segments and angles. So getting into some more segment and angle related proof. LM is, or so up here we're told LM is 5, and so you could label this up. LM is 5, KN is 5, that's those two lengths. And then LM is congruent to LK, so they're telling us that LM is congruent to LK, so this segment here is congruent to that segment there. So LM is 5, KN is 5, that was given, and they've kind of done this thing here again where they did half of it on that line, and then LM is congruent to LK. Let's find that, that's down here. So there's our other given statement for this one. So then LM is equal to KN. So we knew that these were both, we never actually have shown that. We show they both equal 5, but 5 equals 5. So we could think of this either way. We could kind of substitute KN for 5, or we could do like transitive property. So this is either substitution or transitive property, whatever way you want to call it, with just this previous statement here. LM is equal to 5, KN is equal to 5, so we can substitute in LM for 5 or KN for 5 or transitive property. / transitive property. All right, so then the next statement we can make is that the segments are congruent. That's kind of where we want to start getting towards here. So LM, segment LM is congruent to segment KN. And that's because their lengths are the same. That is the, and so we can, we know that's congruent now. Those two are congruent to each other. That's the definition of congruence. I'm just going to do a little congruent symbol to be lazy. And then KN, so then we had our given, LM is congruent to LK, so LM is congruent to LK, so we ultimately with KN is congruent to LK. This is basically a substitution or a transitive property again. We replace this LM with the KN, from up here, or we can call it substitution / I'm just going to do sub / transitive property to finish that one up. All right, and continuing a couple more on the back. We have, if L is the midpoint of GR, prove that GL is half of GR and LR is half of GR. We have two things to prove here. So first of all, L is the midpoint of GR, that's our given. And then GL is congruent to LR. All right, that actually is just because we know we had a midpoint. That's the definition of midpoint. All right, and so then GL is equal to LR. Those lengths are equal. That is from the definition of congruence. All right, so then GL plus LR is equal to GR, that full length. So that's the segment addition postulate. And we can do a substitution then. GL plus GL equals GR. So we had GL plus LR. Well, we know GL is equal to LR, so we're going to substitute in GL for that LR and get that substitution. Property there. So GL plus GL equals GR. And then we have 2 times GL, so that's actually just combining like terms. 2 GLs is equal to GR, and then we're going to divide both sides by 2, so that's our division property. Both sides have been divided by 2 to get GL is equal to 1/2 GR. And then, so that's actually one of the two things we were trying to prove up here, so we'll check for 1, we've done that part. And then LR is equal to 1/2 GR. We can do that here by substituting. We knew GL was equal to LR, so GL, we can substitute in LR, so that's substitution, which wraps up our other half of our proof. All right, last one here. So the measure of angle 3 is 40 degrees. I'm going to go ahead and write this in my picture over here, 40 degrees. I'm just going to label it up to help myself remember. Measure of angle 1 is congruent to angle 2. Remember, these pictures aren't always drawn to scale. That does not necessarily look congruent, but they're telling me these are congruent, so I will believe them. These two angles are congruent to each other. I'll mark it as so. And then 2 is congruent to 3, so 2, that angle is congruent to 3 as well. So in fact, that means all 3 of those angles are congruent. We'll get to that. All right, so we have 1 is congruent to 2 and 2 is congruent to 3. That is given. They actually did half the given again, and then the measure of angle 3 equals 40. That other part of the given is down there, so I'm going to go ahead and pre-label that. So then the measure of angle 1 is congruent to measure of angle 3. So this is going to be from either from these 2 statements here, that substitution or transitive property I mentioned. So I'm going to write substitution / transitive property. And then the measure of, if the angles are congruent, then their measures are equal. That's the definition of congruence for angles. If their angles are congruent, then their measures are equal. The measure of angle 3 equals 40. And so then we know the measure of angle 1 equals 40 by substituting it in. Measure of angle 3 equals 40, so we can either call that, again, substitution or transitive property, whichever one you want to call it. Using this and this line here. Substitute it in, measure 40 for that, or transitive property A equals B, B equals C, A equals C. And that wraps that up. Sorry about the copy here. This page, the very next page in the notes packet, is a duplicate, and the back is blank, so you just don't even need that one. Sorry, that was a miscopy.